continue from where we left last time. And last time we were talking about basics of networking. We talked about types of network. We talked about networking models. We also touched a few things to do with topology. Now today I wanted us to talk about the internet, but before that, I really love for to do something extra, something on networking devices, so that we all get to understand that a router is not a switch is used to do this, yeah, those kind of things. Now that we know the kind of communication medium we use, or communication channel, I think, we use in networks, it's a good idea that we also get to have devices that we use. So last time when we were talking about topology, and I said topology is the structure of your network. How your network looks like the structure yake venye imejipanga, we call it topology. And there are a number of them. We saw like around 4 or 5. But there's this one unique one. We call it star topology. And we said in star topology, we have one central device, then every device to that network connects to that central device. That central device in a network, we call it a hub. That is the native name for it. We can have as many as we want. So anytime we want to add a computer to a network, we have to connect it with that central device. That is computer 1, 2, 3, 4, and 5. Then this is our central connection. This is the most common type of topology we consume everywhere for small networks. If you talk about the larger networks, you'll find the topology being a possibility because they can combine a few, especially if you're working with voice IP or VoIP, or even if you work with cameras, you'll find a tree topology coming in. A tree topology ni ile combine more than one topology. Once a combine star na another one. Yeah, we call it tree topology. Now in these simple network, this is just a simple network. We have this central device we call it a hub. Now this can be cabling, this one can be wireless, it can be wired, it's wired, we know it can be LAN cable, Ethernet cable, or the one called distinct pair, it can be coaxial, it can be fiber, but let's go with what we see and what we know. These are just LAN cables, and these are just computers 1 to 5. Now, last time I also mentioned that computers, and I don't want to say most computers, all computers or any device that can be used or can be added in a computer network only has one Ethernet port. Even if it's a server, just one, it can't have 2. So it's kind of hard for us to connect 3 computers together. It's possible for me to connect 2 because 1, 1. But if I have 3, becomes impossible because I can only connect like this or like that or like this, but I can connect this connection like so all at once. It can't work. So in such cases, we now come in, a central device now comes in to aid you in the connection. So that central device, we have said it's called a hub. There are different types of hubs, depending on what you want to achieve. The earlier form of a hub was called, it was called a hub. Nowadays, we call it a switch. And I'll show you one. Give me a second. Okay, I was saying, if I'm still audible. Yep, I was explaining, I was saying, if you want to connect more than two computers, you need something central so that you can achieve what you want to do. And that central device, we call it a hub in computer networks. There are a number of them. Nowadays we call it a switch, but the earlier form was called a hub. A hub and a switch, they are more of the same. Different is just the intelligence of the device. Now for a hub, let me use an example. If I'm sending a message from computer one, I'm sending a message from computer one to maybe computer three. I'm just saying hi. Hi, just saying hi to computer three. If this information reaches this hub, what the hub will do, it will broadcast or send to every other station connected to it. So it will send to 2, it will send to 5, it will send to 4, it will send to 3. That is a hub, the earlier form of a switch. A hub is not able to differentiate if this is as I mean, it's not able to recognize separate devices. Hiyo inajua tu information ikikuja, it has to send to anything connected to it. And that's why nowadays we don't use it unless you want to perform what we call a group network or a group task. For example, if you have a lab and unataka anything you'll need to perform on one computer, it will be similar to every other computer. You can use a hub so that you'll just do it once, then the hub will broadcast to every station connected to it. But what if I just want to talk to computer 3 alone? That's when we now use what we call a switch. But this switch, you explain in a, oh, sorry, I'm supposed to have my video on. If you are to explain a switch is become a splitter. You people, I don't know if you know a splitter. Like kama unataka connect kuwa na display kadhaa, and you only have one decoder, unatumianga something we call a splitter. Ama or a charger, you want to charge different phones with the same charger. You buy the splitter charger. Iko na USB, iko na type C, iko na nini. Switch ni kama hiyo. Kazi ya switch is just to provide connection for all others. Same to a hub. Now, the difference between a hub and switch is intelligence. We have said the hub in a broadcast information to every other device connected to it. For a switch, if I say hi to computer 3, a switch is able to identify that this message, hi, is only for computer 3. So when this information reaches here, it will check something we call the head of that information. Usually information inakwanga transmitted in form of what we call packet, but I guess I'll repeat that one next week. Now a packet iko na information, then what we call information header. Information header ina contain information about where it's coming from and the recipient or the destination of that information. So a switch is able to read whatever it's in the header and know that this one is coming from computer 1 and is going to computer 3. That's how intelligent the switch is. So that's the difference between these two networking devices, and that's what we use them for. Another one, another type of networking device, we have what we call a router. A router, a rata, whatever you people call it, and from the name it comes from root. The function of a router, it can as well work as a central connection, by the way, and that is the intended function of a router, by the way. It's also a central connection, but it's a central connection for networks. When you want to connect different LANs together, you use a router. For example, let me have another network here. This is a central connection. Like so. So these ones are all connected here. So let's say this first network is network A. Maybe it belongs to a department of maybe academic department in a school. Then these are the network. I'll call it B. B with 4 computers, 3, 4. belongs to another department, let's say that was academic, this one can be finance or even administration. Now the challenge is all these networks have to operate as one because they're using maybe the same server or they're serving the same institution, same purpose. So how do we come to connect this computer, this network and this network? Some will say, hey, connect a cable from the central connection of computer of network A to network B, like so. Zoop. Yeah, you can do that, but you won't achieve whatever you wanted. So how you do it, this is gonna cost me. It will cost. Okay. Now what you'll do, you'll need to have another central device for you to connect multiple networks together. Now this central device is what we call a router. Router connect networks together. Switch and a hub connects computers and devices in a network together. And devices in a network, we said we call them nodes. So switch na hub ni connect nodes together. Router connect networks together. Yeah, that's the difference, but all of them are being used for central connection. For very small networks that we see nowadays, especially our home networks like the one I have, I don't have a switch. Instead, I just have a router, a wireless one. Then all my devices are connected to this router. I have 3 laptops connected to it via cable. And of course, the other devices connected to it wirelessly. So this is my computer 1, this is 2, this is 3. And that one is real, by the way. Then I have my phone over here connected to this router using what we call waves or Wi-Fi. So you can see then this route of mine is being connected to the network, to the internet by someone called ISP. So in the internet. So you can take and see that the router is bridging me in this network and another network we call the internet. We say the internet is a network. It's a type of wide area network or WAN. So my router is connecting the internet, which is network A, and my small network, which is network B. So that's how it works. But instead of using a switch, which will be costly, I just buy a router alone because a router can still act as a switch nowadays. Before it couldn't act. But again, this one is limited because if you find a very big, a router can never have more than 5 ports, but a switch can have as many as 48 ports, even 96. Yeah, we still about that. We will see about that on next week. But for router, you can only limit it to 5. So if you want to use it as a central hub, just make sure you can only have more than, less than 5. Yeah, I really don't know why Lucy is the only one who usually have problems getting me. Earlier today, I had a problem with my network, and I think it's almost still there. But the good thing is I'm recording, so I'll get a chance. But anyway, hang in there. Maybe it will resolve. I was saying, a router only has 5 ports. So if you're choosing a router as a central connection, make sure you'll never have more than 5 physical devices connecting to it. But if it's wireless, you can connect as many as 255 or even more if you want, if you play around with your configuration. So that is a hub, switch, and a router. There are other networking devices that we can still talk about. I think I just mentioned them. We have a router. Okay, I will together with the last time one. I realize I'll go forward. But if they don't forward you just keep checking your class. Most links are usually there. Kama sijatuma class, that means that video is not on YouTube as public. You can only find it. You can only find it in your classroom as a link. Okay. Where's my marker again? Where's my marker? Okay, now the other device, I just mentioned them. We have antennas. Antennas of so many names. I'll give you an example of a few. We have this thing we usually call a beamer. Inakaa kama dish. Maybe it's a dish, just not satellite dish. But it's a dish. Inakaa kitu kama hiyo. And it's mounted to a pole. And usually point in a specific direction. Ukienda tu iguse bahati mbaya, watu wanatumia kitu watakulaani vibaya, because it usually maintains a straight line of sight. I think after the break I'll talk about the internet, so you'll get to understand why they maintain a straight line of sight. If you explain the internet, I'll talk more about this one. The other devices, we have something we call a bridge. Bridge more works as a, it's just like a router or a switch. It can be used for the same purpose. The other one is what we call repeaters or boosters. This one I doubt you'll ever get to meet them physically. Repeaters or boosters. Now this one, what they do is just to amplify the signal. If it's going weak, or if it receives a signal in amplify, in a sense, and receive like this. Some of these antennas that perform that function, and you usually see them outside. If you walk around, you'll see these tall structures by ATC. Mnazitanga booster. Zimepaintiwa white, right, white, right, white, right. Kuna vitu zimewekwa hapo, usually white in color, zingine zinakaa keyboard, some are circle like dishes. Yeah, all of them are called repeaters. They receive signal, amplify, send. That's what they do. Is there other networking device available? There are so many, but these are the most basic one you play around with them. Over the internet ni tu router 1 iruke router ingine, iruke router ingine, hivyo. Ikifika kwa organization kuna router, kuna switch, kuna devices. We don't have complex things in computer networks. We don't have 1,000 devices. There's one I've left out. Kuna moja inaitwa access point or AP. Access point is more of it's a router switch. Why access point connects wireless devices, connects devices wirelessly to a network. So anytime I want to connect to a network wirelessly, and we are so many of us, I'll opt to use an access point. In kama tu router ina kubridge wewe na network ingine, ama niseme ni kama switch, it connects a number of you together. Yeah, so that one is an access point. You can configure it as a router, as I've said. You can still use it as a switch. So, main purpose of it is to connect devices wirelessly to a network. It's also a central device, an intelligent one. Okay, iko kitu ingine nimeacha about networking devices. I think this is what we'll deal with mostly. Hizi ndio tutapatana nazo. This is what we'll be using. This is what we'll be configuring. Talking of configuration, I have an example of a router here. This is what mostly people use. Najua kamera yangu inaonyesha na selfie, so you can't read the name, but it's Tenda. It's a famous brand in Kenya for making these wireless routers. So these can be used as an access point because it's a router and it's wireless. That means you can connect device wirelessly to it. I don't have it here, it's just the box. But if you check at the back of it, it only has something like only 3 ports. One which receives information from a different network, then is zingine that you can use them to connect your 3 devices. So if I was to have a very large network with physical devices that they won't need wireless connection, I won't buy this. I'll buy a router. I'll buy a switch, I mean, with so many ports. Then allow me to put something here. Okay, I was struggling to pull this. This is a switch, eh? The switch you can see. This one is a 24-port switch. They're 24 for T. They're 24. This one is 4, 4, 4, 3 times 12, 2. This one is a 24-port switch. So you want devices big like desktop computers or even laptops, and you want to connect them. You can use this one. So you can power in, then you can connect your devices. This very first port you can connect a router to it. So let me draw it. Let me clear my drawings. Let me draw. This is my router over here. It can be wireless. Then my router is connecting me to the internet via maybe an antenna or something else. Well, maybe it's fiber. Like so. So this is my switch here. This one is from which company? 3Com baseline switch. It's yeah, the company is 3Com. Right. 2024 is the type of switch. Yeah, switch pairs are gonna type. We shall be using mostly Cisco types of switches, so prepare to learn most of them. So most of them maybe to just 24 port, but a different name. Ni kama venye laptop kuna HP na but HP ni mengi, kuna HP ProBook, kuna HP Lightbook, sijui kuna HP Notebook. Yeah. So for switch, again, it's a 24 port switch, but there are so many types. This one is a 2024 3Com switch. Oh, okay. Now I'll connect my router to this first port like so. So my computers can be here. So port 2 na connect here. Port 3 na connect here. Port 4 namna hiyo. Yeah, hivyo to all of them. So if there are 50, you'll need an extra switch. But if they are less than 24, this one will do, eh? This one is very expensive. This one is 9,500. You don't need to worry. There are smaller routers that can cost as low as 1,000 or even 1,500. Hata 800 unapata. This 5-port switch, 8-port switch, 16, but 16 expensive case. But you don't have the smallest one Nishai Grana is a 3-port switch. I was wondering what was the point of making a 3-port switch. It's more of a splitter, but I know it's a switch. Before we go for a break, I'll want us to explain something, but I think si lazima. Nyie watu kuna haja mimi niwaambie importance of a computer network. It's much obvious, but ziko kwa notes. You'll find them in your notes. Importance of a computer network. Where can we apply computer network? Surely. One of the people using computer networks is you, like right now. So even in a car, I was installing something. I don't know if it's done. So before you implement such kind of a network, you'll need what you call a network diagram. And a network diagram, ni kama kuchora tu. It's not that complex. Not that complex. There are a number of programs you can use to draw. You can use Microsoft Word if you are good at, inserting images, but the best one you can use is called draw.io. Why do we use that? Because it has most of these networking devices icons, like icon for a router, icon for a switch, icon for a computer. Yeah, as in it gives you the visual. So if you design a network, at least mtu anaona hii ni computer, hii ni router, this is a room, this is what. Yes, so I think I'll get the link for getting this draw.io utaipata kwa your classroom. You can find it there. Anyway, let me wait for it. But as we wait, let's talk about the internet. We all know the internet, we use the internet, but only few of us have an idea of how actually the internet looks like in terms of the structure and how it works. Part of how it works, I know we shall cover it from next week, but I'll just give you an idea. To start with, the internet is not wirelessly. The internet is wired. I told you last time, 85 to 90% of the internet is fiber optic, or it's hardwired. Like physically, kuna wire connecting A to B, B to C. I'll give you an instance. Right now, there's someone watching a video on YouTube. We all know YouTube is not in Kenya, neither is it in their phone. YouTube is in somewhere, I don't know where, or a social app like Facebook. We are using Facebook, but we don't have Facebook, the whole of Facebook in our phone. We only have an application. The rest of the information is being kept by someone called Facebook. But for Facebook, I know it is. Facebook, it's in West California. I think it's one of their servers. There are a number of them. Users on the internet are able to share information from computer A to B. And if we say computer A to B, computer A can be a server. We talked about servers last time. Now, I'll use YouTube because it's the best example. Now, YouTube is from Google, the company. Kazi yao ni kustore video ya watu. If you wanna do something video so that people worldwide can see, you can upload to YouTube. So YouTube, they have computers. On these computers are servers. And we said last time, characteristic of servers, it's a multi-user computer. It has very large storage and it has very crazy speeds, by the way. So that is just what YouTube is using. That's why you can stream at very high speeds without a delay of even microsecond. So this is YouTube. All these I'm drawing here, they're just servers. They're stored here. There is a person here with a laptop, and they're watching a video on YouTube. I think after the break, I'll explain in detail how this one works. But for now, just know the laptop is connected to YouTube, and this connection, most of the journey, because YouTube is away from Africa. So from where the YouTube servers are, kuna cable imetembea. Ikafika at some point, ikakuwa wirelessly, maybe they're using beamers, ama nanos, or just very high speed strength antennas. Then ikakuja ikakuwa cable tena, ikanikaribia again ikakuwa wirelessly. So that is the connection from all the way from YouTube to your laptop. But most of it, I'm saying it's cable. And I'll explain that one after the break. We are going to have a break in the next coming 2 minutes. It will log us out. Then in 2 or 3 minutes, please log back in, so that to maliza hivi tu haraka haraka. Anyway, I was saying most of these journeys is cable. this physical connection. Then of course kuna number of people, not just this one. Kuna mtu mwingine hapo, kuna mtu mwingine hapo, kuna all of them are connected to YouTube, watching different stuff or consuming different products or videos. Kuna huyu watch movie, huyu watch documentary, watch maybe a reality show on YouTube. This one is watching a movie that was uploaded on YouTube. Now there's a way computer networks are able to identify that this one is watching a documentary and not music like this one. There is a way in identifying. You call an address, and allow me to call it just an address for now. Just like mailing. Just like mailing. Think of mailing venye ilikuwa inawaka. Hiyo kitambo ya posta, unaandika barua, unaweka kwa envelope, still napeleka, wanatuma, inafika. Hiyo barua ilikuwa inafika aje penye inaenda? How are those guys able to tell that this one is going to Kisumu and not Nairobi? Because of an address, that PO box something Nairobi or Kisumu is the address. In computer networks, we have something similar to that, but it doesn't have PO box. But yeah, it has numbers. So that's how mailing identifies that this letter goes to that destination and not the other destination. In computer networks, that one is the same. Okay, there's something we call a path. There are different paths from the YouTube servers to your phone. It can go the longer way, the shorter way, the normal way. How is it able to identify that this is the way and not the other way? Again, how does mailing service work? If I'm writing a letter from Meru and I'm taking it to Nairobi, the only path you can take is Meru, Nairobi, and not Meru, Nyeri, Yende Nakuru, Yende Western, it comes back. No. Okay, let's go for a break, then let's come back in. Tasa, in just 2 minutes to log in back. So see you after the break. And how actually the structure of the internet looks like. Last time I said people have theories of how the internet works. This is one of it. This is how the world looks like. The world is oval according to geography. Iko jamaa hapa. Simon, this one is you. And this is someone else. Naomi. So this one is different continent, a different country. Also this one, this one is the Earth surface. So this one makes communication to this one. We have that theory that above the Earth, we have satellites. Like so. So we have to make communication ni chup 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 chup. Ifike kwa satellite. Then kuna downward link like so. So ukipiga simu inaenda kwa satellite alafu chini. If you does the same thing. If you're calling someone from the US, it is the same thing. I mean that's the theory. You need you to. That's what I used to know and what most people know actually. But no, internet doesn't work. It never that way. Such kind of model, what we call satellite internet, was suggested by Elon Musk. You people know Elon Musk, but it's something I think it's working for him. But it requires you to have a small satellite on your place so that it can be received. Now, the disadvantage of this kind of communication, that's why it was never adopted, is this. The distance from the Earth's surface to where the satellite is, it's around 22,000 miles, 22K miles. So that means signal yangu ita travel 22,000 miles uplink and another 22,000 miles downlink. That is a total journey of approximately 44,000 miles wirelessly, not wired. I mean, how powerful is that? This very long distance for wireless communication experiences something we call signal inakuwa weak So signal ikitoka hapo, by the time inafikia hii satellite, it's already very weak. But the satellite again, it has repeaters, it will boost it, then itume chini. But again, by the time inafika huku chini to where I am now, the signal is weak. So this kind of communication, mtu yangu, kupatana ni kitu hamtawahi fanya. So how does it work? So this is how it works. Allow me to clear my everything. And wait, okay. Let me draw Africa. Hii ni Africa. The internet consumes something called which are fiber optic. Yeah, there's Africa. You should give me some marks for drawing Africa mzuri. This one is US. This one is Europe. You know, I'm just drawing the map of the world. It looks like China wako huko na watu wengine huko. You have another US down here. I don't know. Sijafanya geography. Okay, Facebook iko huko juu. Facebook servers. YouTube yao iko huko, by the way. Sijui ni country gani, but I know it's just there. Then we have our lovely country, Kenya. Kenya nakaa hivi. Ouch. Almost forgot Somali. That is the world. Internet is a physical structure. Kuna time fulani ulikuwa unasikia ati China connect sijui na Kenya, sijui something of the sort. No. Let me give you a recent one. In I think 2020, Huawei wanted to lay a cable from China all the way to some country. I think Miami. They connect to Miami. But they, watu wako wakakataa because walisema China itakuwa inatumia hiyo link ku steal information, blah blah blah. Yeah. That's how actually people are connected worldwide. The internet consumes undersea cables. Hapa ni Indian Ocean, huku ni ocean nyingine, sijui inaitwaje, huku ni ocean nyingine. Now we have cables connecting continents na zinapita under the sea. These cables are fiber optic because we said fiber optic are the best in terms of transmitting over very long distances. So we have fiber optic connecting this continent, connecting Africa, different countries. Ni venye nyinyi mnachagua. If you're a landlocked country like like Kenya, mnasema from the internet. How do they do it? See, we have three. We have one from Google, one from Amazon, and the other one comes from China. Ile iliweka around I think 2013. Yeah, we have those three in Kenya. So from the Kenyan port, we have three fiber optic zenye zinatu connect kwa internet. Now this fiber optic run to different servers. Kama za Google, of course, na run to wherever their servers are placed. Google has multiple servers. Ziko US, kuna ziko China, the South Africa. Yeah, all over the so kuna kasava tu tajua line. Something else about fiber optic, it can go up to around 75 to 95 kilometers. Then signal yake ikuwe weak. So as a result, these fiber optic zinatumanga together with copper for power. So after some 80 kilometers, kuna katikati ya ocean, kuna kitu imekuwa huko chini, we call it a repeater. And of course, we have said a repeater inafanya nini? Yeah, amplification of a signal. So after 80 kilometers of this fiber optic, as the signal is growing weaker, of course imetembea na power yake. Yeah, copper zina power hizi repeater because it's power. Then ina amplify, then inatuma another 80. So kuna hizo vitu zimekuwa laid under the sea. By the way, you should go to YouTube and watch some of these documentaries. They are fun if you love tech. about undersea cables, fiber optic, the internet. Anyway, let me explain, ndio utapata fani ya kuona. Okay. Okay, sawa, tumeconnect countries, so aje sasa internet aje. Remember, YouTube servers over here iko kwa border, iko karibu na iko mbali, so kuna venye imeconnectiwa pia kwa land na fiber optic up to hapa kwa sea, by the way, and it's a very secure place. Ukikuja hapa umanage kuniniza cable, umekata connection ya what YouTube, wewe utakuwa umetumaliza. But anyway, there are very high securities for such connection, and I usually think the reason as why walipitisha under the sea, one of the reason is security, because some places kulikuwa na option ya kupitisha pia over the land, which again is very expensive. You'll need to get permission kuchimba chimba mashimo. Imagine michimbe tunnel, inapita kwa building, inapita kwa nini, you'll have to pay a lot of money for that. Undersea cable inahitaji tu pesa market, that's all. Okay, so hii itakuja iconnectiwa na servers za YouTube. Remember, servers are just computers. Imefika hapa Kenya. Ikifika kwa the Kenyan port, kuna mtu mmoja anakuja anasema, ngojeni, mimi ndio nachukua charge hapa. Who is that? Of course, is the government of Kenya. Most people usually think connection ikuja to a country is usually private to some sectors. No. The CS for ICT says that the government does not own any network. That one is a lie. The government cannot fail to own a network. The Kenyan general network is owned by the government. Okay, ikifika hapa, the government takes over, ina receive this fiber optic. Then ina distribute kwa watu wamejitolea kuuza hii connection. Hao watu wanauza hii connection wanaitwa ISP, Internet Service Providers. Internet Service Providers ni watu kama Safaricom, Telcom, Liquid Telecom, Knet, Airtel, name them, there are so many. Najua nimemention Liquid Telecom na Telcom. Liquid Telecom ni government iko na shares kidogo, pia Telcom. But Knet is entirely for the government. Actually, Knet stands for the Kenyan Network. It is the biggest ISP. Hiyo ndio inagawa kina Safaricom na wengine. Okay, how does it distribute? Kuna hizi vitu tunaonanga huku nje zinaitwa boosters. Very tall structures za chuma, then juu kuna madish ama something looks like a triangle. Those are antennas and connection ikifika hapa, hiyo fiber itakonektiwa ipeleke penye kuna hiyo tower moja. They are usually called signal booster. But booster is a less main way because they usually boost signal main purpose. Zinakaa hivyo. So hiyo inakuja inakonektiwa hapo. Ukiangalia booster mzuri, utaona kuna cables zinatoka chini zikifuata ka channel fulani zikipanda juu. Yeah. It can be fiber. Ikifika hapa juu, of course kuna antennas. Hizi antennas ndio zina connect sasa end users, kina nyinyi sasa na mobile phone. Wewe Simon alikuwa hapa. Simon, allow me to draw you. Even though I've never seen you, but I know that one is you. That is me. So for a very short distance, wirelessly, these antennas connect our phones to that tower. Then your tower imeconnectiwa by fiber, blah blah blah, ikuja hapo kwa the Kenyan port. You're getting the idea though. Okay, now that means watu wawili wako na simu hapa, if they are talking and they can hear each other perfectly, it's because they are closer to this antenna. If one of them moves far away, they'll experience what I was saying last time. Akisikuski unakatika katika. That's the same problem. Okay, how does Safaricom now distribute this thing countrywide? They use the same towers. Of course, hii kuna tower 1, kutakuwa na tower ingine after distance. Of course, hiyo signal inaendanga according to the power of the antenna they are using, ama according to the power they have. It can go from 8 kilometers, 16 kilometers, 25 kilometers, or even as far as 80 kilometers. But kitu bora inafaa ujue, after that kilometers, they'll need something we call a repeater to boost that signal and distribute to end users again. So hii tower again inatuma signal kwa tower ingine iko some 80 kilometers away. Hiyo tower pia same structure, same features, same devices. So iko namna hiyo. But for some of these towers, they are connected wired. That means fiber imetoka kwa hii tower 1 ika-connect kwa hii tower 2 fiber. Like it's a physical connection. But because of we know that hii connection inakuanga na shida ya permission, upate kuchimba hizi mitaro, it takes a lot of time. You see, for wireless unaweka tu structure, then configuration ya done. Kuchimba lazima uchimbe, ukuje uweke, ufunike, uende ukate ma license. Kama inapita kwa building uwepeshe, ama uambie watu ya building niwapee pesa nipite katika. It's a long story. So most of these towers are usually connected wirelessly. That's why ziko mingi because they are not connected via cable wirelessly, but it's for a very short distance. The other thing, they have to maintain a straight line of sight. That means nikikuja tu nijenga hapa building, nimewamaliza, nimeua Safaricom. They have to make another tower kando hapa to make sure signal inatuma namna hii. Yeah, that's why if you go to towns or cities with very tall buildings, you'll find a lot of these towers actually. But ukienda Ushago ni moja hapa, ingine huko. Yeah, it's because in towns there are buildings that block the line of sight for these towers, so they have to make a lot of them. These signal towers are not constructed by Safaricom or Airtel or Kenneth or Safaricom. Inaundwa na kampuni moja inaitwa ATC. If you've ever heard of ATC, American Tower Company. They're in charge of building these structures, and one structure can cost as expensive as more than 3 million. Actually, one of it wanasemanga ni around 3.5 million. Hiyo structure kujenga tu, wajeka mtu hapo kujenga tu. So akijenga, Safaricom inakuja ina rent, Airtel wanakuja wana rent, wengine kina Telcom wanakuja wana rent, inakuanga hivyo. But if you're very keen, you'll identify that some companies wanaprefanga their own structure. Kama Safaricom. If you ever find these towers with 3 legs, Safaricom. 4 legs, Telcom, Airtel, also Safaricom can use that. But I usually see 3 legs, najuanga Safaricom hawawezi kosa. And some smaller ESP. Anyway, so that's how the internet works. So if you're connected to the internet and you're using mobile data, ni short distance kidogo tu. Ingia msituni uone venye hiyo data yako itakusaidia. That's how it works. But again, we said we have addresses over the internet. So devices are being identified by what we call IP address. And these servers, where information that is we need or we usually like, they have something else we call a domain. Domain, okay, kuna address. Let me just stick with that. They are addresses. Addresses are numbers, usually kama ni kidogo sana, around 32 bits. That is 1, 2, 3, 4. If they are kama ni kidogo sana ni 4 digits. But the human mind cannot comprehend digits. You can't, even if you are a genius. Well, okay, utashika some, but not all of them. Imagine ushike address, physical address na Facebook, ushike ya YouTube, ushike ya website ya shule yenu, ushike ya beshte yako, juu mnatumia WhatsApp, ushike sijui ya nani, like all those IP, you can't. That's why you can't also, kama for number pekee ni issue, IP address itakuwa rahisi. So as a result, they came up with something else that will make it easier for the human mind to comprehend, and that's what we call domain name. Domain name in a standing for the IP. So for example, Facebook ni 41.2 something, in a represent which domain? Facebook.com. Domain ni ile .com, .co.ke, .org, .ac.ke, .org, .xyz, we call them domains. So domain inamapiwanga kwa IP address. Kuna address, but ni ile tu you can't cram. Because when you're searching, you're supposed to search the address. Yeah. but it's easier for us to remember alphabetic than numbers. So hivyo ndio inakuanga. So kuna hizi domain names zinamapiwa hapa. And by the way, let me use an example of your phone book. Internet has something called a DNS, domain name servers. The work of a domain name server ni kama phone book, ni kama phone book ya the internet. Ina keep record ya IP address na the corresponding domain. So when you make a request, is the domain name system, which again is maintained by an American company. There's a name hapa, I'll give you. So when you're searching anything unaandika facebook.com, it will go to the phone book, which is now that company, which is in charge of maintaining domain names over the internet. Na iangalie hii jina ina correspond na address gani, then it picks the Facebook na inakufungulia. Kama ina correspond to a number of them, it will give you a list in Google. You'll see facebook.com, Facebook what. Itakupea list. Wewe mwenyewe uchague ni gani umetafuta. There's a company that handles that. So just the same way, CEO, there's a name, something American company. Nikikumbuka jina I'll give you. It's not INA. Iko jina hapa. INA ni kama broker. Venye tu wewe uko na phone book na huwezi shika namba ya kila mtu kwa kichwa as much as umeshika ya wasee kadhaa. When you want to call your friend, you won't dial the number, you'll search the name. Ndio ugonge ndio dial number. That is the same concept kwa domain name system. You search the domain name, then it will give you the corresponding IP address from the servers that do that. Yeah, they're called DNS servers, domain name servers. Yeah, for configuration, we shall talk more about this one. Ina keep a record of that. You can actually have your own. Unaweza amua sasa department fulani nipatie careers.something.com from my domain. We call them subdomains. If you have subdomains, you can have your own DNS so that anytime you click on that, it can correspond to the respective IP of that request. And I think by this, yeah, in brief, that's the internet. I don't think there's something else I need to explain. I'll give you the name of that company that manages DNS servers. That ours, it's called ATC. Hey, by the way, ukinafanya huko kazi wako na pesa. Ndio uko engineer. Because they're mostly company. Ama wako wale wasewa. And they're very secure, by the way. If you want to know how secure it is, enda kwa mlango ya any of these tower alafu guza hiyo panel. Enda tu guze panel. Utakuja unipigie story. They're very secure. In fact, anytime they want to do a change or a configuration, ama anything wanataka kuchange kwa hii, they usually come with security. Kama ushaangalia mzuri, they usually come with there's a security company that works with ATC inaitwa there's a name hapa. Hata kama wewe ni ka small ISP kama wenye wanatupeanga wifi huku, sijui Swift, sijui Mawingu, sijui Sprinkle, sijui what. Yeah. Kama wako na one of the antennas hapa and they want to maybe kuna change ama wanataka ku replace something ama it's not working, they have to call ATC waambie tunataka kwenda ku make change. ATC will give them an escort. You're wondering why? Mbona ufiche chuma? Because watu kama Al-Shabaab wakipata access to this, unajua this tower actually will give you access to the Kenya's network. Now once you have Kenya's network in your hand, my brother, my sister, wewe tutakupigia magoti tukuombe. It's a very risky place. That's why you'll find in places like Turkana, mahali penye kuna vita watu wakaingi sana, you'll never find these ATC structures. Hawezi yeka huko because of security. Yeah, that's why hizo places usually suffer from matter of network. But nowadays they're usually trying to solve that problem using what we call balloons na pia kuongeza there's something called DBM. DBM ni power your antenna to make sure your antenna it can a little bit stretch more than 8. Yeah, it's called yeah. ACANA. Yeah. There's a company that manages DNS. Hey, you're good at research. Piano, that's the skill we need. What was I saying? Yeah, that's how ATC sahi inafanya. Ina increase your DPM. Kama walikuwa na consume 240 unapata wanapewa extra power na kinyi power. So that hizo antennas ziende mbali and using something we call balloons. 2020 kulikuwa na rumor ati Google wameleta balloons ndio sijui watu fulani wa access the internet remotely blah 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 for online what. Those kind of balloons is the ones I'm saying. But they're not very effective because of signal loss, because they have to travel uplink and downlink. Zinakwanga pia na shida. But anyway, if you've ever gotten a chance to work with such companies, I know it knows a lot about these stories. If you don't know, end that after documentaries, they're usually good. So now at least I'm sure you understand how the structure of the internet looks like and how actually it works. So even though in a work, and if you try to compare it with the mailing service, right, it's more of the same. Kuna package, message, but now in networks, that message, your letter will transmit in a network, we call them, they're called packets. Information are broken down to something we call packets. Then packets in a information, then something we call information header. A packet is, a computer will represent a packet by there using an envelope. Yeah, tell you a computer network mimics the mailing service exact in terms of everything. So a packet iko na data na what we call information header. Information header ina tell details like where is it coming from and where it's going. That is the address of the sender and address of the receiver. So any device packet itajipata hapo. The device will check, hii inatoka wapi? Oh, it's coming from YouTube. Okay, where is it going? Oh, it's going to, okay, so it's going to Kenya in a route. Ikifika kwa device next, again it checks. So it sends until it finds you. That's how it's able to identify. So guys, unless you have questions, there's a bigger story again. Whatever I was installing here, I think it, yeah, imemaliza. Whatever I was installing, it's done. If you have a question, niwapigie story ingine. Oh, next week we shall be covering IP address, and I think it's good for me to mention that anytime utakuwa si must. Kuna wase wanatakanga network. Unasikia shule fulani wanataka computer network. Wanataka network ya computer because their school, you know, it's old and it never came with these things. Or any organization, before you give them kama waitolia network. And if I say network, I'm not talking about the internet or Wi-Fi. Like network to connect computers out to the same network so that they can connect to the internet or so that they can talk to each other. Mtu akiwa kwa principal anaweza call na zile simu na mtu akareceive mahali, or the secretary can send something to the examination na ikuwe printed bila mtu kufanya kitu yote, bila mtu kuamka. Yeah. So for such, you'll need to design a network for them. That one I'll do it. Installation and configuration of packet trace, I'll do it on Monday. For now, I'll just show you once you install draw.io kidogo tu in 3 or 5 minutes, then call it. I was saying, before we kuja install watu network, you have to draw it kama tu venye architect anachoranga nyumba kwanza. If you draw it, you'll come and make a simulation of that same network and try to configure and do some of searches. Uone kama nikiwa hii department kama there's access, yeah, before actually you go and implement. Why? To avoid problems of misconfiguration. Ama umeinstall network vizuri, umelay cable zako fiti sana, but network yako iko na shida yenye hata wewe huwezi explain. Like you can't troubleshoot a network umetengeneza wewe mwenyewe. So you'll need such kind of tools. You design, uoneshe copy how the network will be looking like. Once you're done, come to a simulation program like Packet Tracer, which we'll be doing next week. Tengeneza your network, like from from entry internet to every department ama every subnetwork wako nazo, then try to see if they can see each other perfectly, if they can work perfectly. If they can work perfectly, that means ukiimplement itakuwa sawa. Ukipata shida, correct it in your simulation and correct it in your diagram so that ukienda kuimplement ama kuinstall, you won't have problems. And that's one thing watu wengi wana mess up, by the way, but for medium networks. I only have 5 minutes, so let me open. So to install draw.io, just click on the link. It will open your, it will open for you Microsoft Store. Then you click install. Yeah, let me share. Okay, this is how it looks like when you open it for the first time. So you can simply just say create new diagram, and I call it net1. You can pick any if you want. Since not in a network, anyway, I'll pick a blank one, then say create. Once you create, scroll huku chini. Currently, you don't see anything concerning network, so you click on more shapes. Then teremka huku chini under networking. Then you can check Cisco. Cisco 19. Network. Just anything that deals with network. VMware. Business, we don't do with others. No. I may need cabinets for very large networks. Networking, I think I just needed this one. Azure, Cloud Enterprise, just anything concerning network, Google Cloud Platform, IBM, this is the mutation. I'll click on apply. Okay, once you click on apply, if you check on your left menu, you will see them. Chini kama kuna networking. Yeah, ziko mingi. You can, there are routers, kuna security, kuna servers, kuna storage. So switches, if you click switches, there are a number of switches. So simply drag and drop, like so. So let me drag a switch. Let me drag a router. Yeah, like how that's how you draw it. On Monday, I'll show you one actual diagram I made for some school some time back, a few months ago. Niliwachorea, then and I'll show you how I did it and how it looks like at the end. So if you want computers, where can I find computers? Again, if it's not there, you simply come to more shape and look for it and simply click on it, click where added. So that's how it works. I just wanted to show you guys that. But ni kama kuchora, but you can still do it by hand. Si lazima utumie the software. If you're very good at doing so, that this or you can draw and label. It's okay. You can still you can use triangles and these are the ones to represent building. This can be a building. Maybe niweke to draw them fast. Weke router hapo, switch kwe hapo, then yeah. I don't think it's going to is, but basic action networking, I think that someone to know about computer networks. You need to know the internet, you need to know networking devices, you need to know of history, computer networking types. That is in terms of the cable, maybe it's wireless what technology. Basically, uh, you to do a lot of research because again, introduction to networking, kuna mtu anaifanya kama unit for 4 months. We learned in just a week, actually 3 days of talking. So just I'll advise you to go and do more research on that if you are still new to computer networks. But again, it's not something very hard. Make sure at least you understand something about the network you are. Like right now, you know your phone has something called an IP address. That's why you are able to browse on the internet. So next week we shall be talking more about this and it keep getting more fun. So ndio tukifika kwa hacking, or I mean ethical hacking and penetration testing, you actually understand how a router works. You are able to know that nikifanya hii nitajiseti, nikifanya hii niko sawa. And I told you are competing with some other people called blue team. You are red team, so make sure it gets you up. So meeting notifications until next time, which is a Monday. Allow me to say adios, muchachos, for now. Peace. Yeah, I need coffee.